A, let we obtain the equation of motion of expectation value of an operator, and also from that we can give the future of a commuting operator. That is, if A commute with Hamiltonian, then A is expectation of A is a constant of motion. So what we want is the time derivative of the expectation value of A. Let we derive the expression for that. Substituting the expectation value of A as psi star A psi d tau. So differentiating the terms psi star A psi. Three terms we are having. So first differentiating psi star, keeping A psi constant, and then keeping psi star constant, and third term is, so next I am going to use Schrodinger wave equation IH cross dou psi by dou t equal to H operator psi. Okay, so substituting for dou psi star by dou t and dou psi by dou t in first and third term, we will be getting -1 by IH cross H operator psi star A psi plus psi star. The second term we are having as it is, and third term again substituting for dou psi by dou t, we are having 1 by IH cross H operator psi. So combining the first term and the third term, as H operator is a self-adjoint operator, we can write this term as psi star into H. So we are having psi star H operator A psi. This is the first term. I am writing here the third term. Yeah, psi star A H operator psi. And the second term we are writing is so the first term and the second term we can combine and write psi star 1 by IH cross H operator A minus, sorry, here minus so this term I can write as 1 by IH cross expectation value of the commutation bracket. Here minus sign we are having, so we can interchange the term. So this is A H operator, commutation bracket of A H operator, plus this is the expectation value of dou A by dou t. So here D, this is the expression. So here if the operator A is explicitly time dependent, the second term becomes 0. So we will be having the D expectation value of A by dt equal to 1 by IH cross expectation value of the commutation bracket of A comma H operator. This is the equation of motion of the expectation value of A. So using this we can evaluate A, and what is the future we are going to obtain from this. This is a commutation of A comma Hamiltonian. So if A commutes with Hamiltonian, then the terms become 0. So the left hand side term also becomes 0. So from this what we can say, the expectation of the operator A is constant. It does not vary with time. So since what is the significance of it? Since it does not vary, it remains constant. So it is easily measurable and observable.